Hello, welcome to lesson 3.6. This is about solving compound inequalities. The objective is that students will be able to solve and graph compound inequalities, and the standard is ACED point 3, which has to do with constraints of inequalities, and we'll see what that means. Back here. So there are actually two different types of compound inequalities that we're going to learn about. We've got and inequalities, and we have or inequalities. So for the and compound inequalities, those graphs are going to actually graph together. And the variable is going to go in the middle of the inequality symbols. So an example would be -2 is less than x, which is less than or equal to 7. And for the graph of the or inequalities, that is going to graph apart or in separate directions. And you're going to create two separate problems when you are solving this. It's going to be two totally independent, different problems when you have to solve. I didn't make that line very big for me there, for myself there. And this is like trick or treat. So you get one or the other. You don't get both. That's why they go apart from one another. And the and inequalities, it's like saying you want dinner and a movie. You're not choosing between the two. You're including them together. So they graph together. Then the apart, it's like the trick or treat, which I think is happening this year still. It should be happening. An example of the or inequality. X is less than 3 or x is greater than 5. Yeah, trick or treat better be happening. It's my baby's first Halloween. I want to see costumes and candy. This is usually, almost always, it's one or the other. We're going to jump in to do some practice problems. It's the best way, I think, as usual, to kind of see and understand, especially when we are graphing. So that's what we want to do first. We want to graph each piece. So x is less than or equal to 2. Now, our number lines are blank, so I'm going to pretty quickly here just label them. Let's see, where do I want to start? So you just want to make sure you've got some labels on there so you know what, where you're starting and what your little lines represent. So we're going to start with x is less than or equal to 2. That means we have a closed dot. This is throwback to our last lessons. If you need a refresher, go watch that video again. Because it's or equal to, we've got a closed dot, and x is anything less than that. So it's all of this. Or x is greater than 5. It's either of these options. They're graphing in opposite directions because it's an or inequality. So x is not going to include 3 or 4 or anything in between there, and it doesn't include 5 either, actually. But x is less than 2, so that's 1, 0, -1, da, 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 da. And x is greater than 5. So it can be 6, 7, 8, 7 million, 12, whatever, right? Anything bigger. But what's in the middle here, this is not included. So that's where the constraints come in. So we are not including 3, 4, 5, or any of the little decimals in between there. They're apart from each other. So it's one or the other. All right, I think I've explained that enough we can see it, right? Now let's talk about and. X is literally in the middle. So we're going to start. We've got 1 is less than X, and X is less than or equal to 4. So X is less than or equal to 4. That's a closed dot at 4. And we're going, but X is also greater than 1. So we have to stop at 1. X is anything in this middle portion here. It's not on the outside of that. So X is going to be greater than 1. So it's bigger than 1 here, but it has to be smaller than 4. So it's only counting the in-betweens, right? It's this and that. We can't keep going past 1 because that's not included. So you just do one piece at a time and make sure that when it's an and, it's your X or your variable, your answers are going to be right, sandwiched in the middle, just like X is literally in the middle right here. For real. So now we have to see a graph and turn that into an inequality, a compound inequality. So here we can see it's an and inequality because it's graphed together. So X, we can start with X, or any variable you like. We almost always use X, right? It's going to be in the middle. It's this part. X. We have an open dot and an open dot, so we know that our inequalities are not or equal to. So X right here, it's bigger than 0. See, it's greater than 0. And it's less than 5. X is literally in between 0 and 5. So we got 0, X, 5. It's right in the middle there. Now the next one is an, and I guess I should write that this is an and this is an or inequality because it's graphing apart. We've got two totally separate, independent inequalities here. So we'll start on this left side, and we've got X is less than or equal to, because it's a closed dot, -1. X is anything smaller than -1. Then we've got our pause, our break in our action, in our graphs. So it's or X is going to be, and this is closed dot, it's greater than 2. So it's anything bigger than 2. We got two totally separate problems. The one more step that goes along with this is then actually having to solve these inequalities, just like we were doing in the last lesson. Like I said, if you need to review, you can go ahead back to lesson, it was 3.4, I believe, about solving inequalities or multi-step inequalities. We're just adding this other piece to it, so it should not be too bad. I will review it, but a little more quickly than when I broke it down in the first lesson. Now I've included the most tricky OR problem and one and problem so we can see how to do it. So for OR problems, the actual solving part is very simple. We're just going to split it in half and do one at a time. That was a horrific line. That's okay. So we're just going to solve one, then solve the other independently of each other, of one another. So as a review, then when we're solving, we want to get x by itself, and we do the same thing to both sides of the inequality. So I've got 7x is greater than 35. I need x alone, so I'm going to divide both sides by 7, and I end up with x is greater than 5. Or, and we're done with that. We don't have to bother with it anymore. Or we have this side, we're going to solve the same way. And we have to divide by a negative here. And when we divide by a negative, we have to flip our sign. So we get x is greater than 8. Now the reason that this is the most tricky OR problem is because when we go to graph these, they actually are going to run together. Or they're going to overlap. They're not going to be together. It is still one or the other. So we've got x is greater than 5 or x is greater than 8. X is greater than 8 is included there. See, like x is greater than 8. Anything that's greater than 5 is also greater than 8. We don't need to put that dot there because everything that is included, it's still an OR inequality. So it's still one or the other, but in this case, the graphs just overlapped. Okay, so now that we've got that tricky one out of the way, and that is on your assignment, let's do this AND inequality. Now, for the AND inequality, it's a little different than what we've done, but it's not necessarily too much trickier. The only difference is whatever you do to the middle, you have to do to both sides. So normally I say you do the same thing to both sides of the inequality or the equal sign. In this case, you're going to do the same thing to all sides. So this is where it's really helpful, I think, to put your little dotted lines, your dashed lines, as barriers in between the three pieces of the problem. And you'll see what I mean in 1 second here when I say we do the same thing to all sides. We're going to subtract 20 from the middle, from this side, and from this side. We have to do the same thing to each piece of it. And that's the most tricky part about solving and inequalities, is remembering to do the same thing on every little part. So we got negative 63 is less than or equal to 9x, which is less than 18. And now we need to get the 9 away from the x, get x by itself. So we're going to divide every piece by 9. See how we just have to add one more little spot here when it's and, because x is in the middle? So negative 63 divided by 9 is 7. Negative 7. And we've got x in the middle. So it wasn't too terrible. I hope I didn't build it up too much to make it scary. And let's look at the graph of this. And I'm just gonna not going to fill it all in. We've got a closed dot here at negative 7. And negative 7 is less than x, but x is less than 2, so we got to stop at 2. So we've got an open dot on 2 and a closed dot on negative 7, and x lives in between here. So that is how we solve and OR. Yeah, I didn't know I could do that. I got 2 lightsabers at once. Right, didn't I? Where'd they go? Oh. Anyway, that's how we solve and OR inequalities. So for OR, we do 2 problems. For and, we do same thing to all sides. And that is all there is to this lesson, and I hope you have a great day.